What do astronauts and pirates have in common? They're both at risk of scurvy. Now, that might sound like an awful joke, but it's not. It's actually the truth. So at the moment, all of our astronauts are kind of in the International Space Station. They get regular supply of food. As we kind of move away from the space station and go towards like bases on the moon and bases on Mars, then food deliveries are a bit of a problem because it's just too far to get food up there regularly. So we'd have to look at astronauts and people in the colonies kind of like growing their own food. So that's where things like scurvy and stuff can become a real risk again, the same as it was for piracy. You know, we could get things like food pouches and stuff, but they're only going to last a short amount of time, and they're not as good a replacement as fresh fruit and vegetables. So you've got things like oranges for vitamin C to help with scurvy. The other major one is fruits, berries, and nuts, and other kind of antioxidant foods are actually help with radiation resistance, which in a lot of places once you leave Earth, there's a lot of issues of radiation. So having that slight advantage from your food is very, very helpful. So let's start with growing food in space. How hard is it to do? Well, there's two main issues that you kind of have to overcome when growing food in space. The first one is gravity.
We're just trying to overload the commander here with these M&Ms and see how quick he can catch them. We're pretty quick.
So, there's no gravity in space. So a lot of our plants and our farming systems are designed with gravity in mind. So most obvious one is, if you water your plant, first of all, tipping water on a plant won't work in space. The water won't tip. It'll just kind of float. But let's say you could pump the water into the roots of the tree and like in the dirt and stuff. Well, the water will just float out of the soil because there's nothing to hold it there. So you need a way to keep the water in the roots so that the plant can actually drink it. The other main issue is light. So the International Space Station goes around the planet every 90 minutes. So for 45 minutes it's in daylight, 45 minutes it's not in daylight. So you need to make sure to provide it with light. So you can do this with like grow lamps and like powered by solar panels and stuff. But you need to provide it with light. Similarly, you know how humans have a circadian rhythm? So, we like getting light for roughly the same amount of time every day. In winter, we struggle because there's less daylight, and in summer, we also struggle because there's too much daylight. Plants are the same. They have a circadian rhythm. So you'll see this in the mornings, plants are all closed up, and then throughout the day, they'll open up to get more daylight, and then as the sun kind of sets, they'll close up again. If you see any time lapses of plants throughout the day, you see they track the sun, and then also they open and close as like the day kind of goes on. If they don't have this rhythm of a certain amount of daylight per day, then the plants get very stressed. They don't grow as well, so it can become a big problem. The other things as well we have to kind of think about when growing plants in space is getting water. So in space, water is pretty hard to come by. The only way to get it really is to either recycle the water around you, like dune style, of have some sort of condenser. Or getting water out of urine and stuff like that. That's kind of what we do at the moment in the space station, which is manageable for a few people, but if you've got, say, 100 people on a ship, that's a problem. The other solution would be to park on a comet or an asteroid that's covered in ice, and you can harvest that ice and turn that into water. The other issue as well is nutrients in the soil. Obviously, plants consume nutrients, and they need that to grow. So on the International Space Station, you can get supplies of fertiliser, but as things go on, if you're doing a deep space mission, it would be quite difficult to get fertilizer. So you could overcome this by, instead of having one plant, so let's say you're growing raspberries, right? You normally just have a raspberry plant in a plant pot and that's it, and you kill everything else that's around it. Instead of having one plant, like a raspberry in a pot, you could have multiple plants in there and they have a symbiotic relationship, so they help provide nutrients to each other. This would be simulating more what nature is like. When you look at a hedgerow, there's lots of different plants there that kind of all work together to help each other grow big and strong. Whereas traditional farming is you just have one plant in a field and then you spray it with fertilizer and stuff. So that might be not justifiable in space. Okay, what about growing crops on Mars? So Mars is a bit easier than the moon, and we'll come to that in a minute, but let's start with Mars. Of course, the elephant in the room is the Martian, which is all about, a guy growing crops on Mars. How truthful is this? Well, the main issue you see he has to deal with is getting water for his crops. Since The Martian has come out and been written, we now know there is more water on Mars than we thought. There are still parts of it that are deserts, and then it's very hard to find water, and there's no lakes and rivers, but there is water in the dirt that we didn't realize was there. It would still be easier if you had your Martian base in like the poles, like near the North Pole where there's more ice, or in a crater that's in shade, there'll be ice there as well. So you could harvest that and make water for your plants. But the main thing is that the Martian kind of covers is you can't be shipping water to Mars. It's too far away. Water is too heavy. Similarly to space, Mars has lower gravity, so it does have some gravity, but it's much lower than what we have on Earth. One thing we kind of see in space is human bones get weaker when there's less gravity because we don't need them as much anymore. We see that in the International Space Station where there's no gravity. On Mars, the gravity on Mars is about a third of what it is on Earth, so it's significantly lower. But we haven't had people on the Moon or Mars for long periods of time to see what that would be like. The reason why I mention this is plants actually have a bone-like structure called lignins. I think I pronounced that correctly, which kind of help the plant to stay strong. If these kind of bone structures in plants also break down, how will that affect the plants? We don't know if these bone structures do break down, and if so, what the effect will be. So we need to kind of understand that. One big thing that the Martian deliberately avoids is radiation. So Mars has a very weak atmosphere and has almost no magnetic field, so it's significantly more radioactive than Earth. This would make it much harder to grow crops. So there was a study done with cress and rye plants to see how well they grow in a simulated environment of Mars's background radiation. What the study found was that cress grew about 32% smaller and the rye plants grew about 48% smaller, so that's almost half the size. So this is a big problem. They also found in their study that there was a lot more browning of the plant, so bits that we wouldn't be able to use, and a lot more dead parts of the plant as well. So this means you'd probably have to grow your plants inside so that they're protected from the radiation. The other issue is light. So Mars is about double the distance from the Sun as the Earth is, and the relationship between distance and light isn't a straight line. So it's not, if you double the distance, you get half the amount of light. It's actually a 1/² relationship. So this means if you double the distance, it's actually a quarter of the light you get. So that means the light that the plants would get would be much weaker and they wouldn't get as much energy out of it. So photosynthesis would be much slower. Of course, this is a moot point because if you're having to grow your plants inside for the radiation, you're probably going to have grow lamps and stuff for them anyway. So, but it's just something to be aware of. And similarly, with the days are different lengths on Mars, so you need to simulate that circadian rhythm anyway to try and make it seem like it's an Earth day. Over time, those plants might adjust, but for now, it's a problem. Another thing we kind of take for granted is pressure. So on Earth, the pressure is much higher than it is on Mars, and this is a problem for plants. So on Earth, if you're at sea level, the pressure is about 1,000 millibars. If you're at the top of Everest, it's about 200 millibars. And wherever you live is probably somewhere between this. And of course, there's good days and bad days. It depends on the weather, but roughly this is where our pressure kind of sits. On Mars, the pressure is about 6 or 7 millibars. So that's less than 1% of what the pressure is on Earth at sea level. We can see what the effects on pressure are on plants here on Earth. If you take a plant that grows at sea level and take it up a mountain, we can see the effects of pressure on it and how reducing the pressure affects it. If we understand what pressure actually is, so pressure is literally just something big above you pushing down on you. So at the bottom of the ocean is extreme high pressure because there's a lot of water above you pushing down. The same is if you're at sea level on Earth. If you're on land, then there's a lot of air above you pushing down, lots of gases up there. As you go higher, there's less gas above you because you're higher up in the atmosphere, and then there's less stuff pushing down on you. What that means is if there's less gas pushing down on you, there's less gases for the plants to breathe, so to be able to do photosynthesis, so in this case it'd be carbon dioxide. What we see happens on Earth is if you take plants higher up, because there's less carbon dioxide, they can't do as much photosynthesis and they grow smaller. On Mars, either you need to grow your plants inside in a pressurized environment, which would be very expensive, or you need to grow more plants to make up for them being smaller. So, there's two different ways to do it. Either way is not easy because, if you're growing it inside anyway to protect from radiation, you need to build a bigger area to get to make up for the plants being smaller, or you need to pressurize the whole thing, which would be very expensive to build. We talked about soil health on the International Space Station, getting fertilizers and stuff. What is the dirt like on Mars? Well, Martian soil is actually much better than you think it would be. So that's good news. It's full of nitrogen, phosphorus, and potassium, everything that plants need to grow. So that's really good. You can still make fertiliser out of poop if you need to, like they do in the Martian, and that would just help, the plants grow a bit bigger. The bad news is there's also some really harmful chemicals in the soil on Mars as well. So these are made up of chlorine, and they are in such high quantities that they are poisonous to the plants and they are poisonous to humans. So the plants will not grow very well, and then if you eat any vegetables grown in Martian soil, then they would be toxic to humans, so not a good idea. The good news is NASA did do a study a couple of years ago where they looked at bacteria and seen if bacteria could break down these chlorine chemicals into something more healthy and less harmful, and they found that this would actually work. The bad news is, we're going back and forth here, the bad news is if you have the bacteria outside in the dirt, the ultraviolet light from the sun is much higher because there's less of an atmosphere on Mars, and the bacteria will break down and die. So you need to be doing your soil processing inside. So you might have one big room for growing your plants, another room next to it removing the harmful chlorine chemicals from the dirt so you can use that on your farm. So yeah, swings and roundabouts here. Okay, let's look at a few other places in the solar system that we could potentially look at growing crops and how difficult it would be. So if we look at Venus, our closest planet, Venus is extremely hot. It's over 400 degrees and it's about 90 times the pressure of Earth. So not a great place for growing plants or crops. The only plants that might survive is any plants that kind of grow at the bottom of the ocean next to geothermal vents where it's really hot. Those ones might be able to grow on Venus, but other than that, anything else would just die. Mercury is kind of similar. Mercury in the day is around 400 degrees, and at night it's around minus 200 degrees, so no plants could survive that kind of extreme temperature change. Humans would struggle as well, so basically the only way to do it would be inside in a protected environment. The moon is also one to think about, so it's very similar to Mars. The only difference is there's no atmosphere at all really. There's almost no gravity, so again you'd have to understand the effects of gravity on plants. You'd have to provide it with an atmosphere and the gases it needs to breathe. The moon soil has almost no nutrients in it for plants, so you would have to find a way to make soil or ship it up there, which would be very expensive. So that would make it a little bit difficult. The other kind of remaining places in the solar system are either gas giants, so things like Jupiter and Saturn, where there's no physical ground to grow your plants in, so it wouldn't really work, or they're extremely cold, so things like Neptune or any other moons are all icy and cold, so your plant would just freeze. And even if they could grow, then they would need artificial light because they're just so far away from the sun, there'd be no light there for them at all. So yeah, it's good news and bad news. So basically, if we're looking at colonizing Mars, we would be able to grow our own crops there, which is a good sign. Easier than we thought, but it's still not super easy. So yeah, there'll be some stuff there to learn and try and figure out how to do. Anyway, thank you for watching. If you like this video, you might like my last video talking about how the red spot on Jupiter seems to be dying. Storm that's been going on for hundreds of years and it seems to be fading away. What's going on there? Find out by watching my last video. Thank you for watching and I hope I'll see you in the next video.